Let's take a look at differentiating using the chain rule. The first thing we need to understand is, when do we use the chain rule? The chain rule is used when you have a function inside another function. For example, here we've got 3x inside in the sine x function. Here we have x squared inside in the cos x function. Here you have 3x plus 5 inside in the ln x function. Here we have x cubed inside in the e to the power of x function, and so on and so on and so on. There are a couple of ways to use the chain rule. One is to use a formula which contains u's and v's, but I prefer just to use the method where you understand what's happening, where you just do the differentiation yourself without need for a formula. So let's have a look at a couple of examples. The questions I'll do this question here, we'll do this question here, and we'll do this question here. So we'll do those three questions. I'll do an example of each of these for you. Right, so the first question, y is equals to the cos of x squared. Y is equals to the cos of x squared. So first of all, I'll bring back over my basic derivatives. Remember, if y is sine x, then dy dx is cos x. If y is cos x, then dy dx is minus sine x, so on and so on. Now, these only work like this in a straightforward manner if it's just an x inside the bracket. If you just have an x as the inner function, it differentiates simply like this. However, if you have more than an x, if you have another function inside the brackets, then we need to use the chain rule. And we have this right here, the cos of x squared. Right, so how are we going to use the chain rule? Well, we know that cos x differentiates to minus sine x. So in this case, we can say that dy dx is equals to, well, if cos x differentiates to minus sine x, then the cos of x squared differentiates to minus the sine of x squared, times, then we zoom in and differentiate the inner function. So differentiating the inner function, differentiating x squared, that is 2x. So dy dx is minus the sine of x squared times 2x. Tidying that up, dy dx is equals to minus 2x sine x squared. Okay, let's move along to the next example. The next example we have here is y is equals to the ln of 3x plus 5. Now, remember, the ln of x differentiates to 1 over x. So the ln of 3x plus 5 will differentiate to 1 over 3x plus 5 times, once again, you zoom in and differentiate the inner function, times the derivative of 3x plus 5, which is 3. So in this case, I can tidy this up and say dy dx equals 3 over 3x plus 5. Moving on to our final example here. Y is equals to e to the power of sine x. E to the power of sine x. So e to the power of x differentiates to e to the power of x. So therefore, e to the power of sine x will differentiate to itself to e to the power of sine x times, once again, times the derivative of the inner function. So times the derivative of sine x, and the derivative of sine x is cos x. So times cos x. So we can call that dy dx is equals to cos x times e to the power of sine x. And that is how we do the chain rule. So we differentiate the outer function, and then we zoom in and differentiate the inner function. So the best thing for you guys to do would be to practice the remainder of these questions, keep an eye on your solutions, and for access to questions, solutions, graded quizzes and more, visit www.limbymaths.com.